got to my second favourite aeroplane, the A-18. Again, this one is a true multi-role fighter aircraft. We didn't have to make it work in the multi-role modes as we do with the Mirage, but it came with all that capability built in, so it's an impressive little aeroplane. Not so little, as you can see, but I was fortunate enough to do most of the first flights out of the factory when we assembled it down at Avalon. The routine was bought under a foreign military sales program, and the aeroplane belonged to the US Navy until it was delivered to Williamtown or Tyndall and accepted by the RAF. So the process they used in the US was the contractor, McDonnell Douglas, would fly the aeroplane for 2 or 3 times to make sure the product was built correctly. And then the Navy, US Navy, would then fly it for a similar 2 or 3 flights to accept it, make sure it was acceptable. So we followed that routine down at Avalon. I was assigned as the McDonnell Douglas pilot. So I did the first couple of flights for half the program, and then Brian Robinson took my role and he carried on from there, and I went across to become the acceptance test pilot. So I worked for the US Navy for the last half of the program and accepted the aeroplanes into service. So the actual test flying was pretty straightforward flying. We'd do a couple of flight control checks at 10,000 feet, then climb the notional tropopause, 36,000 feet, and take it out to a maximum Mach number, which was only Mach 1.6, 1.7. And that was because the intake is a simple intake, whereas the Mirage had a complex intake. It could go to Mach 2.5. This one would stop at about 1.6 because the intake would choke and build up a huge wave of air in front of it. So you didn't have enough thrust to push through that drag. Yeah. So that's the only reason it wouldn't go faster. Obviously, when they designed the aeroplane, they decided, probably out of Vietnam experience and a few other skirmishes around the world, they didn't need the extra high speed. They've taken that time-space domain out with weapons. So these days they carry weapons that can actually travel further distances and at high speed. So that's how they've compromised in that regard. And this aeroplane was designed more for manoeuvre than it was for high speed. So delightful aeroplane to fly, very easy to fly. It's fly-by-wire, of course, so and it's what the pilot does in cockpit, he manoeuvres the stick or the rudders to command a particular rate of change in one of the axes, or the pitch, roll or yaw, and then the flight control computers manoeuvre the control surfaces to achieve that command. So that's how it works, and so it's very predictable, very reliable, and quite manoeuvrable as a result of that. Because it was designed as a digital aeroplane, can carry a whole range of weapons, both anti-surface weapons, anti-shipping weapons, air-to-air weapons, and they can be integrated relatively simply through software coding. The only hard part then is the actual physical attachment onto the aeroplane, but in the design stage they did a lot of work designing the underwing pylons and the pylon shape and capabilities themselves. So the F-18 served us for a long time. I first flew the aeroplane in 1984. So I went across to the first cadre of instructors and did my training on the aeroplane. And at that stage, our first two-seaters were both at Patuxent River. They'd been accepted at St. Louis out of the factory at McDonnell Douglas and flown to Patuxent River on the East Coast. And I went across to actually, for continuation training and to certify or qualify a few Australian unique modifications on the aeroplane. And the other aeroplane was used primarily by the first instructors just for continuation training, get themselves some experience, and also to work out how much oil the thing had and how much oxy it had for the ferry home, because they'd been instructed to ferry them home in one long leg. So with lots of air refueling. So that's what they did over there at Patuxent River. We just trained air refueling, worked out how much oil the thing was burning, how much oxy it was burning, things like that. Towards the end, obviously we exercised this aeroplane. It's the first time a RAF fighter has been used in anger in the Middle East on a couple of exercises there. It did very well, I gather. I wasn't involved, of course, but I think all the crews that went across with it were very, very happy with the way the aeroplane stood up and the role it played over there. Ultimately, as with all these machines, I think, as I said, we got it in 1984 or slightly earlier, and it lasted till, what, 4 years ago, 2018. So that's what, about 40 years, 36 years, something like that. It's a long time for an aeroplane of this caliber to stay in service. So I think just that alone is enough to say it's now becoming a little bit redundant in terms of the systems on board and the maintenance. Again, it's a maintenance cost. You just can't keep replacing those bits of kit because they all get superseded and they're no longer manufactured. So it becomes a very costly exercise. So like all this machinery, it's got to be replaced, unfortunately. So we decided to join a consortium, an international consortium, to help fund development of the F-35. Originally it wasn't the F-35 alone, it was a couple of aeroplanes that were flying off against each other, and the F-35 was the winner. And once we got involved in that, that's what we purchased. The Super Hornet was purchased. It's a big aeroplane than this one. It's about 1/3 the size again. And it was purchased mainly to replace the F-111. It was actually acquired for a strike function, but it's actually used in the air defence role as well because it's still quite capable air defence wise. So we got a pretty good fleet, I think, with the F-35, the combination of the F-35 and the Super Hornet. Probably don't have quite the strike role or strike capability we had with the F-111, but then again, our posture more is defensive anyway, so having an aggressive strike capability is probably not inside our national policy. So I mentioned that this aeroplane is limited to Mach 1.7. As you can see, it's just got a simple pitot intake. So there's no mice, no cone. All it's got is this, what's called a splitter plate. And so the shockwave forms on here, and at Mach 1.7 or thereabouts, it's just the oblique shockwave is sitting just outside the intake here. So once again, all the air going down the intake is subsonic. This little porous handle here takes the boundary layer air, which goes down here. A lot of it's ejected overboard above the wing, and a lot of it is exhausted through here as well, just to take care of the pressure changes. So that's how our simple intake works, and that's why this aeroplane can't go faster than Mach 1.7. But it has 4 hard points out on the wing. There's 2 outboard here on the folding panel as well, and those 2 there. And they can carry a multitude of weapons. These are a bit limited in the mass they could carry, just because of strength.
Right.
And then it's got the tip carriers for missiles, for the heat-seeking missiles. And it's got chin stations on the sides of the intake for radar missiles. I don't know if you can see those there. Yeah, see just there beside the undercarriage?
Yeah.
That's where the Sparrow missiles go.
Okay.
And as you can see here, this is a vertical ejector rack. It can carry 2 1,000 pounders. So the US Navy, because they use 1,000 pound bombs, and that's because that's the most explosive effect in the space they have available in their storage on a carrier. That's whereas a 500 pounder takes up almost similar space, but doesn't have the same explosive effect. So they compromise with a 1,000 pounder. I like the 2,000 pounder. It does real damage. It's a massive weapon. The laser guided bomb is about 18 feet long. So what's that? 6 meters in length. So it's a bloody big weapon. And we can carry 4 of those on these stations. Yeah. This is a fuel tank, 330 gallon fuel tank. Yeah.
Yeah, cool.
And on the centerline pylon there, you see that's a forward-looking infrared tracker sensor and laser tracker.
Mm-hmm.
So that's what it does. So if you're carrying laser-guided bombs, you can see the target through your screens in the cockpit, and the laser stays pointing at the target until the impact.
Even though you've only got a few short spurts on it.
Yeah. Well, as I said, this one's a 20mm cannon. It doesn't look that big there, but they're quite a significant round as well. It can fire at either 4,000 rounds a minute or 6,000 rounds a minute. Typically, for training, they'll send them on 4,000 rounds a minute just to save a few rounds and give you a bit more time of practice. But the actual drum only carries, as I said, 578 rounds. So you do that at 6,000 rounds a minute, you got, what's that, 10 seconds worth of firing? Or less, 6 seconds. But that's a long time. In flight, that's a long, long time. I've tried with the Mirage, in a steep dive, strafing, you just can't, you don't really have the time to fire out a full gun pack. It's just, you're burning up so much vertical space, that even that little time, you don't have time. The other thing I should point out, this is the pitot tube on the Hornet. So there's one on both sides for redundancy. And this is the tube that brought down that Air France aeroplane out of Brazil or Argentina, wherever it came from, because they iced up. So these things are heated, and if you leave the heater on after you land, it burns the troops' hands, and they'll melt these things when they put them on. And this one here is an angle attack vane. I won't take it off, but this measures the angle that the aeroplane is making with the oncoming airflow. So it's just a vane that works, that follows the airflow. And this aeroplane can fly at 30 degrees angle of attack, so say level flight at 30. So it's pretty impressive. There's an issue with air refueling. Around the other side is the air refueling probe. It's retractable. You can't actually see it, but it comes out, you can see that panel there. It comes out at an angle from there. And when you're refueling, of course, the first time I ever refueled was the most unnatural thing you ever do is bump into something in the sky. and it's quite a delicate maneuver because the basket's only about that round and it's made of metal. It looks like it's made of feathers, but it's not. So it's quite solid and quite hard. And what it does as you move in, the bow wave off your nose pushes it up and away to the right. So as you move in to engage, and you've got to keep a forward speed going, otherwise you won't engage. And as you move in, you've got a judicious bit of rudder, right rudder, a little bit of back stick, a little bit of left roll, and then put it in the basket. and then on the actual take-up reel, the reel that the hose is on, it's got a spring mechanism which winds back all the overtake slack. And if it doesn't work, you wind up with a big snake goes up the hose, and it just gets bigger as it comes back, and it rips the probe off. And I've had that happen to me. So, and also the other thing is, if you miss it, you lip the jolly basket. In other words, your probe hits it on the edge. You'll go past it, then it'll fold around the cockpit. It'll wrap itself around the aeroplane, take these probes off, and smash the canopy. I've taken a probe off, taken one of these off. And we do that in night, in weather, clouds, so it's quite exciting at times. These, I'm not sure what these are, but on the nose there is a modern fuse. I've never used one of those fuses, so I don't know what it is. And that's all I can tell, but that's a 500-pound bomb. Or they call it a 500-pound GP, general purpose bomb. We generally train, we don't train with high explosive bombs. That's not quite true. We tend to train with high explosive substitute bombs. So they've got only 40 kilograms of high explosive and the rest of the fuel is a substitute of some sort. So we don't actually use war stock high explosive weapons in training typically. So when you see one of those go off in a demonstration, it's not quite the effect of a real one. So, yeah. This is just a training setup, carries 6 little practice bombs, and they're designed to have the similar trajectory of these things. So the sighting or the manoeuvring to achieve a weapon solution is the same with those that is one of those. The other thing I should say, in the Second World War, when you watch all those bombing movies, the bombs are free fall. They're clamped in the bomb racks and just released, and they free fall under gravity. Modern aeroplanes, once you get above about 250 knots, the airflow around the airfield, around the aircraft is so strong that you've actually got to explosively jettison the bombs. So in these racks here, you just see a piston in the middle of that one there. That's the ejector foot. The hooks are retracted pyrotechnically with explosives, and then the actual explosives then push those ejector feet out and get the bomb away from the aeroplane.